How's it going, everyone? Eulier Gonzalez here again, and today take a look now at the NeetCode problem solution, which is part of the LeetCode solution. As a way to improve is our technical communication and hard skills to develop a pattern recognition when it comes to solve common problems using common data structures and algorithm. All right, this is something that you can find along the way. And the idea here is that we're going to take is 45 minutes to actually solve one of these problems. One of these problems that is here. As well as describe, for example, in our case here. All right. To sum. As well as describe is any challenge and reflections. So far we look at how can we do this. Contains duplicate by iterating through a collection and then verify if that actually is on this particular hash in this set that store unique value. So far so good. And we look at valid anagram. So here it was more about how you're going to work with strings and then transform it to array using the sort method from the built-in JavaScript objects in array that is actually or resort that by the Unicode 16 code units. All right, so that's what we have to, because we have a table, because it compared that with that table, the UTF 18 bits, because you compare that with that table. So you transform that is or everything in uppercase or lowercase. The best practice is with lowercase. So not only that, but also then when you compare each one of those elements, okay, then you say, all right, this is a valid anagram. Okay, so the idea here with valid anagram is that we work with, in fact, let me actually put it here in the part of a reflection. Right? So reflection, okay. On reflections, yeah, reflections. It's like working with strings, okay, working with strings, transform string into arrays, and then sort arrays, okay, the built-in function, sort array with strings, characters specifically, using with the built-in UTF 16, okay, universal transforming format 16 UTF is UTF 16, which is now the expand subset of that unified or unified transformation format, okay. And then how you transform arrays into strings, right? This is actually the reflection from this. So far so good. It's like how you transform with one data structure to another, how you can sort elements in that data structure, and then how you can transform back to string. And here in this challenge, it was more like play with arithmetic. So the challenge here was play with arithmetic and with the data structure, because it's like what's the information you want to store in a hash map, okay. So the two sum was a very interesting, not at all, the two sum was a very interesting project here, because now what we did here is just to using a key here, okay, we have now this collection of value, and we are guaranteed that we are only get exactly one solution, okay? Exactly. So because we're guaranteed that we're gonna get only one solution here, yeah, because we're guaranteed that we're gonna get, yeah, because we guarantee that we only, yeah, because we're guaranteed that we only get is one solution. Because we're guaranteed that we only have one exactly one solution in this array. So we want to find is now, based on this collection of number, which index actually adds up to the target. Okay, and it's exactly one solution, so there are no repeated element here, and we return is this two particular index. So this way of doing that, okay, is by saying we can now have is a map or a set, okay? In this case, it's a map. What we're gonna store is in our values the index, and in our key the value. The idea of this, of the reason of this, is that if we have now a map here, by saying, because we can also try the brute force, but the idea here is by using is this data structure, is this map, where anytime we iterate through that, we're gonna ask, hey, do we have that in the map? No. All right. Yeah, anytime we ask this in our map, we're going to now ask for the difference in that. How so? Well, let me explain that. So that's one of the interesting thing here, because you're playing is with the data structure and arithmetic here. So because when we are doing that and we want to compare this element to this, okay, one way to do that is we say, hey, we can try to figuring out the complementary elements here by iterating to all of these elements, so on and so forth. Or we can say, hey, what is the difference, okay, between this number and that, okay? And if that difference actually match with what we have in any of our keys, then please give me the value at that moment. Which means that give me the index at that moment. And to me, when I figuring out this, was like, what the F is this? So the idea here is that once you have, for example, is this, you know, exactly the two sum, and I get why a lot of companies actually love to use the two sum, because it's actually quite simple, but involved is the use of that structure in a different way as a way to solve a particular problem, you know? So in most of the time we're gonna use our hash as when you're gonna store is the key and the map for that, okay? Yeah, the key and the map. But in our case, because we need to be clear what we're going to store and what will be the output here, what will be the input is one, which is num and target, and what will be the output of this, which is an array of the index, okay? So again, one way of how you can solve this is by iterating through all of these elements and then figuring out what will be actually is what it is. So you evaluate these elements to all the rest of the elements, all right? Or for example, in this case, you evaluate is these elements, and then you go to iterate through this another section. You can do that. Actually, is not performance because it's now is n squared. There is nothing wrong with that. But there is an alternative here as a way to use now this set or this key like this. So anytime you want, for example, is return the two index. Let's go to actually understand when we can find this. Anytime you need to return some index, or you want is to find is the complementary or the target of two index here. The idea here is that you might need to use is a hash map here, and the hash map what it's going to do is to say, hey, in this particular case of two sum is, since I'm going to iterate through all of these elements, a good way to do that is by saying, hey, and also listen to the problem here is that, hey, because now I have this array of numbers and that I need to find which one of those index, at least return index of the two numbers. So I'm going to return these two index that actually match the target. So what I can do here is to, well, find a way to store that, okay, and then check how you can do that. So by looking at the difference here, okay, and say, hey, so when we compare this, okay, in our hash map, when we have in our hash map, what we're gonna store is the value and the index, all right, in that order. So in that hash map, when we store the value and the index, first we're going to start is by asking, hey, do we have this minus this value, which is 5? Do we have that in our hash as we walk through that? So far we don't have that. Or in this case is it's 7. Do we have that, the initial time? No, we don't have that. So let me add this. So I'm going to add is now the key as the current value here, okay, and the value of our map as the index. So when I run to this element here and say, hey, is this difference, okay, exists in our table? Yes, it is. All right, so give me now the index of that position and return this another index in this position, and that'll be all. So I end this evaluation. And this is a very interesting topic, because now here when you say, okay, I got this first element, because this is the first element, this minus the target here, do we have that 3 element in our map? No, we don't. Okay, so let me add this 3 as the index and the position and the value as their index, which is 0, and let me ask that again. Hey, this this minus this, do we have a 4, this difference, do we have a 4 there in our hash? No. All right, so let me now store this as the 2 as the key and 0 as our index. And now it's come to this. Hey, based on this subtraction, do we have a 2 in our index, a complementary? Again, this is the way of how you can look at the complementary. Yes, we have then. All right, so what will be then their index is 1 and 4. So that's quite interesting here as a way to know how you can use a hash and compare and iterate through an array of collections as a way to store data that you can later on compare that. And now in today's, which is this, and now we're going to take a look now at the group anagram, which is now when things become more interesting. Come on. Okay. No, it's because. All right. Let's get into this. Let's get into this. Let's get into this. Is here. Group anagrams. Okay. So, giving an array of strings, group the anagrams together. You can return the answer in any order. Okay. So we are receiving is a. We are receiving is an anagram in a word. An anagram. Okay. Groups anagram. Okay. Okay. What is the intuition? What is the intuition? Intuition. Okay. The intuition here is that we want to group the anagrams together. Okay. We want to group the anagrams together. So what we can do here is to, all right, group the anagrams together. Okay. So our intuition says, well, our intuition says, what is the input? So the input is a string, and we're gonna return is this array of a string, group it. Okay. Okay. All right. Our intuition here says, well, let's go into now store in a hash exactly. Let's now store in a hash our anagrams. Anytime you need to group together that kind of thing, you can do that. Store a hash. Store in a hash a word. Okay. Store in a hash as a key the word and the value the anagrams. Okay. So this is our intuition. Storing a hash key, the key of that word, and all the possible anagrams for that. All right. So this is our intuition. So we got the key, so we got this word, and all the possible anagram. Pretty much like a dictionary. A dictionary, a hash, or a dictionary. Okay. Or a dictionary. Again, remember that after all, this is a way of how you can organize your data. So what will be is the approach of that. Okay, what will be the approach of that? Well, glad you asked. The approach, okay, is something like this. Okay. Yeah, the intuition is stored in a hash dictionary as a key, the word and the value anagrams, and the approach will be like this. Okay. The approach will be like this. It's like, let's going to iterate through the array of string. Okay. Exactly. Check if we got that. Check if we exactly. Check if we got that check if we got that string by ordering. Okay, okay, exactly. Check if we got that string. Okay, if we don't, we add the string. Okay, we add the string. Okay, if we don't, we add the string, and then we're going to compare to all of the elements from that. If we don't, we add the string. Check if we got that string. If we don't, we okay. Check through the array of string. Check if we got that string. Okay, check if we got that string. Or in one run, what we can do is to add all of this string as it is. So that's what we can do here. So we can say iterate through the array of a string and add all the string to the hash as a first iteration, right? Which makes our algorithm already ON. Okay, time complexity, time and space complexity. Okay, which already is making our algorithm is like so. All right, it's making our algorithm is like ON. So the more element we added, the more time will take too. So add all the string to the hash. This is one run. We add them. Now we're going to iterate through the array. Okay, through the array of string again. Okay, and this time we're gonna check. Okay, and this time we're gonna check if we got check if that check if the check if the sorted word in our hash, or you can say check if the sorted word from the nth position is or exists in our hash. Okay, let's go to add the word. Okay, let's go to add the word, and that's it. So so once you iterate through all of this position, and then you are going to add all of this, right, in the second way. Hey, if this actually exists here, yes, it exists. Okay, so add this. Hey, if this word exists here, yeah, it exists. So add this as an array. Okay, let's go to add the word into an array, right? And then once we iterate through all of those elements, all right, let's now is return that. Pretty much return that. So after we iterate through that exactly, and then after that we already have all of our hash there, and the only thing that we want to show is now, well, I want to show the collections of that. So when we can do using ex6 syntax is the show the keys, all right, or show the values. I mean, show the values. Exactly, show the values as the output from the exactly show, and now show the values exactly show the values or show the show the collections of words, which is this, as the output in a two-dimensional array. All right, that's right. Cool. So with that, so that'll be actually what we're gonna do. So now let's go into define is the result here. We can define this as a const by saying, hey JavaScript, I want you to now store is some data here in our result. Okay, and I want you to now create is the how do you put it? I want you to create is the wait, I want you to do this. Anytime you run this function, which will be is an array. Okay, and define here this const, which will store is our anagram. You can say dictionary anagrams, anagrams, okay, which is a map here. So let me now first iterate through this collection and store all of these values in as the key, okay, because that's exactly what I want to store then completely. I want to store them as that key. And then you say, hey, let's go to iterate through strings, but let's go to use this now the iterator protocol. So that's what we use is things like this. You got the keys, the values of the iterator called strings here. All right, I think for access to all of this, I need to use this string iterator protocol, which is entries. I think it is string entries. You can say string entries. Object or entries, no, but from string, set string to string. Really? You don't have that? Bullshit. Me la puse difícil, bro. Hoy me la puse difícil. Hoy me la puse difícil. Hoy me la puse difícil, amiga. Okay. So, you have this. If I say this, for const of value of key and value of a string, for example, A, B, C. But this is a string. Okay, an array of a string. Yeah, if this is an array of a string, of course, it will now going to do that. Say key, followed by the value. Run that. That's interesting. It doesn't show is the C. Why you don't show the C? Wait a single moment. Holy moly, what in the F you... Okay. 2 entries. Okay. Okay. Exactly. We need to actually indicate that this is an iterator, my friend. Exactly. So this is string, which is an array of entries. Okay, so we to get me all of these elements one after the another as a sequence of elements, which is gray here. And then what I want to do is to do this because this is the initial time. You're gonna say, hey, dictionary anagrams, okay, set the value as the value here with empty right now, right? So here there is no value here, or it is null, right? Because we just only want to record all of these words that we have in our map, and then we're going to compare that, okay, and then we're going to compare that here by saying things like this: keys of values. In this case, by again iterating through these elements, but in this case we're going to actually check if we already has that array. So hey, do we have now that if the dictionary anagrams has that value? All right. So what we're gonna do is to say, in this case, his dictionary has that value. All right. So well, I want you to now is set the dictionary. Okay. But again, I need to sort is this value, which means that I need to transform is this value because I need to check this. And this is a sorted word from the end position, which means is that this is now the sorted word, okay, sorted word dictionary, and the other is sorted word from the string, okay, from the array, okay, and here is when I get is this dictionary anagram. So what to do is this. Hey, if that value exists, okay, I want you to now reserve space in memory for these two things that I want you to keep track for the moment, as a way to say, hey, dictionary now I need is to first actually check for both of this. Because I need to check is if they're already sorted. All right, which means is this. So I will need to check at that position, at that value, hey, get me is the word at that value. All right. Or in other words, first I need is to do is this sort of word dictionary, which is the dictionary. Okay, not again. Okay, not again. Okay, first what I need to do is to get this word sorted. Okay, get this word from the collection, sort it, and then get this hash from the collection, sort it. Okay, and if they are the same, add them. So here's the sorted word array. First, as a way to say, hey, the value here, I want you to now transform into a lowercase. Okay. Transform all of this to lowercase. Then split that, which means that transform into an array to be sorted by this by default using is the Unicode 16 table code unit. Okay. And then give me that array, but join that. So give me now this sorted collection, now join it. In other words, as a string. And I'm going to do now is and I'm going now to do is the sorted word. Okay. So what it's gonna do here is to store is all of these elements sorted. Okay, is to store is all of these elements sorted here. Exactly, sorted. Sorted word. And that is actually doing things like this. And that's what I'm going to store here. So now that I have this sorted store value there, okay, in our hash map, okay, all of those are already ordered, sorted. So the next thing that I'm gonna do is that, hey, now I am sure that I get all of these elements stored in my array. All right. Therefore, I go now to actually check if that actually exists here, if that sorted word already exists in the array. If it is, now it is time for me to update that value, which is dictionary anagrams dot set, where you're going to now is, since this is the sorted word, you're gonna say, hey, the sorted word array, I want you to now add this element here, which is push this element here. As a dictionary anagram dot get of the sorted words array. Okay. Followed by the new word here, which is the value from that. And that's pretty much it. That's pretty much it. So when you want to return now this dictionary anagrams, what I want you to return is, say, dictionary anagrams of the values. That's all I want you to return. So there is no need actually to say is this. And we're storing this value as an array for that. Did you mean sort? Exactly, sort. What you can say is to sort it, similar to this, to sort it. It seems that to sort it doesn't exist, which to sort it, that's quite interesting. Oh, because it's actually not allowing that. So you are actually not updating, they don't have that, so you don't return is a new sorted collection, so no problem. It's a now runtime error. Diagram anagrams get is not a function, or its return value is not an iterable. That's right. Okay, so you can do this. All right. Dictionary anagrams get. Okay, so this is now map in JavaScript. You think you're very funny, right? Come on, man. New the data structure, man, not the map. Not the map from array. Exactly. Followed by that. Null, it, and t. Oh, lol. Null, it, and t. Uh-huh. Oh, good. Okay, okay, okay. Mm-hmm. Question. If we do this, are you capable to add that? After all, you need is to wait a single moment. Dictionary anagram dot get of sorted word array. Exactly. And dot push this value. Okay, okay. The issue is here. Okay. Okay, okay. Word dictionary. To transform that into an array here. Oh my god. Because the whole point of this is that I want to transform this into an array. Okay. And then all right. And then add the value. But by doing so, oh exactly. Mm-hmm. So what you can do here is something like this. Hey, this will be an empty array, and then now you have is the proper value here of saying this, of push.value. So what we did is just to here assign this value as a JavaScript object, especially as an array, and then all subsequent value, I want you to now add it to this array for that. You say word dictionary.push doesn't exist, push is not an dictionary anagrams dot get of the sorted word, exactly, of the sorted word is value lowercase dot split sorted join, then join. Okay, and then dictionary anagrams dot set, I want you to sort a word here, exactly, or the word dictionary, and then push the word dictionary to that. And then the sorted word, which is something that we already contained, I want you to now get that value and then push that sorted word. That's right. Sorted word. But because we say, hey, word dictionary.push method does not exist, you know? Well, dot value, but you only accept these two arguments, my friend. And you're gonna set this. Okay, so the thing here is that is the way how we are actually, so I'm getting this value which supposed to be is an array, okay? This supposed to be is an array, and I don't know why you don't want to actually update that as expected by saying is word dictionary. Okay, exactly, is as we expected. All right, but you're telling me that this doesn't exist, so I will need to say is that this is a new array for that. All right, so now that you can have access to this and then say something like this, it's like, hey, the word dictionary dot push the value. Does that make sense? Oh my god. Oh my god. So my question is, what is this value then? You know, what is this value type of word dictionary? It's an object. Okay. As you wish, bro. As you wish. As you wish. As you wish. As you wish. Because here we are creating is this array. I want you to spread all of that, but it say, hey, it's not a function. And now you're telling me that this is not a function. What's wrong with you? You're telling me that this is an object. Okay, you're giving me two problems. You give me a lot of problems here. You're giving me a lot of problems, but it's because no. It's because you don't know how to work with map. That's what happened. You don't know how to work with map, and that's what happened. It's okay, bro. You don't know how to work with maps. I want to work with maps, and you say no, no, you won't. And that's fine. And that's fine. And that's freaking fine. You know, that's completely fine. So now by changing this as it is, and then check if this exists, a dictionary, hey, do you have now this property? Here in object this is object dot object now has on property. Exactly. Is this object has some property? Is this object has own properties? Okay, Jesus. Is this object has own property? Own properties. Get on property names. Okay, get on property names. Exactly. So this is how you say is that get on property name, which is an array. Okay. Get on property names or has on property. So let's see if that actually has that, has on. Okay, so you say, hey, has on, is this object has on property like that, which is dictionary followed by a sorted word. If you have that, okay, then I want you to now do this. So give me that value, word dictionary, which is this, dictionary anagram that, give me that value, okay, and I want you to now is to make this, okay, this sorted word, this sorted word equal to the value that we're getting here. So what are we doing here? Glad you asked. So because now we have to get rid of the map because you are not able to keep up the pace. That doesn't matter. This old legacy visuals terminals and then text editors, good. So because of that, we have to reshape that to this. All right, and then yeah, the dictionary sorted word in that at that key. I want you to now is yeah, with that key I want you to now is to push this value by saying is that you're gonna get the dictionary anagram. So hey, I want you to now with this key, I want you to push is all of this. You know, what I want you to do is this. Because this value is now as an array, I want you to push is the value there. Property value does not exist on empty object. Values. Property values. Line 35. Oh, of course, because now you change that, and now I want you to show me is the value for this, but I think that you won't work because you must have is an iterator for that. Question is that object does have the iterator protocol. So for example, object entries, but I want you to say is the values. Object.value as a way to expand all of these elements here. Okay. And it say, hey, property values does not exist. Entries. No problem, bro. No problem. As you wish. As you wish. So the way to do this is by saying, hey, I want you to now give me all of the keys of the value here, which to me is quite weird. Why don't you show that? Oh, come on. Enough, bro. Enough. Show that. Show that. Show that. Show that. Show that. Show that. I don't ask you for permission. Show that. Show that, man. Show that. Show that. Show that. Oh my god. Show that as an object. Object. Oh my god. Object and number. Okay. We were about to do that because the finicky nature of the object and maps. Okay, what's going on with you, fellas? Your problem is with this, okay? Especially when you are working with object literal and that kind of thing. So object literal. Is a way of how you can access to that. Bracket notation as a way to access the property. Exactly. This is how you say, hey, now you're gonna access to this key. This is the value. So when we are here, okay, working with this, we say, hey, I want you to now assign this to a new array. Okay, all of these other elements, I want you to assign this to a new element. So the first pass, we did it great. So far, so good. Now the second part, which is this, is say, let me sort that word, and let me actually, if that actually exists in the directory anagram, this name exists as a way to say, hey, if this property exists on here, it has its own property. If it is, which of course it has, okay, now I want you to get me the value of that. Okay, I want you to get me the value of that. I want you to get me the value of that. All right. And also I want to take a look at what in the F is this word dictionary at that moment for you, which must be is this array, right? You can do something like this. Give me that array, and then it comes along here. Any fella, chill, bro. And he's returning is an empty object. Why are you returning an empty object, bro? But I am not assigning this to it. Oh my freaking god, bro. It's like, it's okay. Alright. Okay, no problem, bro. No problem. No problem. No problem. No, 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 no problem. No problem. No fucking no, 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 my god. No, no, no. Okay. You got a terrible problem here. And I want you to put this like this. That's all. Motherfucker, what? I don't get it. You have its own word, okay? This actually is working as expected. this actually work as expected. You're gonna have this hash, but oh my god, but what's wrong with nigga, the flying fuck with you, nigga, the flying fuck with you, nigga. The flying fuck with you, nigga. The flying fuck with you, nigga. Alright, Jesus. My fucking God, bro. Oh no. Oh no. No, 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 no. Not at all. The fucking's wrong with you? What in the F is wrong with you? What in the F is wrong with you? Oh my God. Oh, no. Okay. Me, I'm telling you that I want you to get the dictionary anagrams and append this sort of word and assign it as an empty array. What is your problem? Most of the time, all of the errors are on the terminal. Okay, so it's telling that this is not a valid value expected to return this list of string. I already did this. My God, but what is doesn't work with? Oh my God, but what the fuck's wrong with you? I already solved this. Jesus, it's like, what in the F is this, nigga? Oh my God. No, but, exactly, the anagrams group that I want to do this. Exactly. I want to set this as an array. Sort of word. Is that word doesn't exist? Add that. Oh, it's because I'm doing it in the same. It's because I'm doing it on the same iteration. It's because I'm doing it on the same iteration. Really? Oh my God. No, but okay. You don't grade this shit. You don't grade this shit, and I have to pay this problem? Fuck no. Fuck no. Oh, fuck no. Oh, for fuck's sake, no. Oh, for fuck. Well, that'll be all for this video. Take care. Bye.